friends, we all must have heard that light travels in a straight line or a straight path. But did you know we could bend the light? Wondering how? Here's a small trick to show how it is done. Let's take a glass of water. This is a transparent glass filled with normal water. Here's an arrow on the screen. When I pass this glass across the screen, you can see a small magic happening. Are you excited to see the magic? Let's pass this glass across the screen and see what happens. Pay attention. Wow! How did that happen? How did the direction of the arrow change? Wondering how? That is refraction. Refraction is the topic of this video, and let's see how this dreadful chapter is made easy at ShikshaDeep. I'm Dr. Supriya, science expert at ShikshaDeep. Let's take a torch and switch on the torch. We can see a light beam. A light beam consists of multiple rays or a single ray. Let's consider a single ray so that we can understand this topic in the simplest manner. We can see that the light ray travels in a straight line. Now, how do I bend this? Can I take it off the screen and bend it? No, right? But what if I say there is a way to bend the light? Let's take a mirror and place it here. When the torch is switched on, the light reflects in this direction. But what if I say I want the light ray to continue downwards and still bend? Is that possible? Yes. So let's take a glass slab and place it here. When the light passes from here and enters this, it bends. The bending of light is called refraction. Let's visualize this concept. When the laser beam strikes obliquely at the surface of the glass slab, you can see that it bends. This is the laser beam in the air. There is no deviation. But when it passes through the glass, there is bending of the light ray. It is because of refraction. We can define refraction as change in direction of path of light when it travels from one transparent medium to another. Here, medium can be air, glass, or water, or any other material. It is very important to know when light travels from one transparent medium and strikes obliquely at the surface of another transparent medium, a part of light goes back in same medium obeying the laws of reflection, and that is called reflected light. And the remaining part enters into the other medium and travels in straight path different from its initial direction, and it is called refracted light. So a light ray suffers partial reflection and refraction at the boundary of two different medium. Now that we know what is refraction, here are a few examples of refraction. Let's take a glass of water and place pencil inside it. Why does the pencil appear to be bent or broken? This is because of refraction. Similarly, when you look into the pool, it appears to be shallow, but in reality, it is much deeper than what it looks. This is because of refraction. Now that we know what is refraction, it is important for us to know why does it occur. Why do you think refraction occurs? Refraction occurs mainly because of change in speed of light, and change in speed of light occurs due to change in density of the material. Let's take a small video clip to analyze how density and speed are related. This video clip shows people moving from crowded zone to the free zone. You can see people walking in the crowded zone, but as soon as they enter the free zone, they begin to run. Why? There is no space for them to run when they're crowded, but when they enter the free zone, they can move faster. This is the relationship between density and speed. When it is denser, the speed reduces. When it is less denser, the speed increases. So what is density? It is measure of mass per unit volume. We know solid is more denser compared to liquid and gases. Let's go back to refraction. Here the light travels from glass to air, air being rarer material and glass being denser material. It's similar to the video clip that we saw. People were moving from crowded region to free zone. Here light travels from denser region to the rarer region, which results in change in speed of light, which causes bending of light. Here we saw the bending of the light occurs this way. Is it possible for us to bend the light ray this way? For that, we should know few important terminologies used in this chapter. When a light ray travels in a straight line and strikes obliquely at the surface of another medium, this is called incident ray. This is called point of incidence. And when we draw a perpendicular line at point of incidence, that is called normal. And the bent ray is called refracted ray. We also know light ray suffers partial reflection, so this is called reflected ray. The angle between normal and incident ray is called angle of incidence. The angle between refracted ray and normal is called angle of refraction. The angle between reflected ray and normal is called angle of reflection. Angle of refraction mainly depends upon density, whether the refracted ray bends this way or the other way. Keeping this in mind, we can see three cases in this chapter. When light travels from rarer to denser material, the refracted ray bends towards the normal. That is, the angle of refraction is less than angle of incidence. We can remember this as RDT, Rapid Diagnostic Test. That is, rarer to denser results in bending of light towards the normal, RDT. The second case is when light travels from denser to rarer material, the refracted ray bends away from the normal. That is, the angle of refraction is greater than angle of incidence. We can remember this by a mnemonic DRA, like DNA. Denser to rarer results in bending the light ray away from the normal. So remember DRA like DNA. The third case is when the light incidence at normal, it passes undeviated. That is, angle of refraction is 0 and angle of incidence is also 0. A quick recap. We saw three cases. The first case being when light travels from rarer medium to denser medium, it bends towards the normal. Second case, when the light travels from denser medium to rarer medium, it bends away from the normal. And lastly, when light ray incidence normally, it passes undeviated. I hope this dreadful topic was made easy by making you visualize the concepts and also helping you remember them through live experiments and unique mnemonics. As we believe, what I hear, I forget. What I see, I remember. And what I do, I understand. This is how we teach at ShikshaDeep, and ShikshaDeep is very unique from other coaching centers as we use simulations, live experiments, 3D models, and many other features.